my name is Neera Jain. I'm an associate professor here in our mechanical engineering department at Purdue University. And my main areas of research are dynamic modeling, control systems, control theory, and optimization. In my group, the Jain Research Lab, we have two major research thrusts that both build on those fundamentals. The first one is human-machine interaction. So we study how humans interact with autonomous systems, robots, and also something new that's called human autonomy teaming. Thinking about the human themselves as a dynamical system. What does it mean to model a human using the same types of mathematical equations that we would model a car with or some other engineered system? If we do that, we can use those models in the autonomous systems that we build to help them actually adapt and respond to humans in real time. So that's a huge area of research that we work on. The other half of my research group is really on thermal systems, and specifically right now something called transient thermal management. So there's a lot of systems, particularly vehicles, and this can be ground vehicles, air vehicles, and even sea and marine vehicles that are becoming increasingly electrified. Even aircraft are either becoming more electrified, meaning we're just putting more electronics on board for various reasons, or we're actually trying to build hybrid electric aircraft. All of those electronics create tons of heat, and the heat loads themselves are really transient. So this isn't just a steady state heat load that we need to compensate for, but the heat loads increase and decrease sporadically with a lot of uncertainty. And so that's where controls comes in. We really need to use principles from dynamics and control theory to say, well, how do I move energy around these systems to actually keep key surfaces or environments under critical temperatures? And one of the key features of what we do is incorporating thermal energy storage or thermal batteries. So we've been building models of different types of thermal energy storage, integrating those types of batteries into these systems and saying, well, how do I discharge or charge these in real time? What's the optimal way to operate this system so that we can meet all the different performance objectives that we need to and maximize the efficiency of these systems? So if you're interested in dynamics and control theory with some really neat applications, we're doing some pretty exciting stuff in the Jain Research Lab.